Hey, geometry class, welcome to our unit on volume. On what? On volume. I get it. It's a unit on volume. So we're going to talk about some interesting things with volume. But before we do, we need to understand some general concepts. Let's get into that. I'm going to start with our general concepts using units of measure. So we have to understand units of measure before we get into volume. We have to consider what we did in one dimension. So in one dimension, we had just a particular one dimension that's dealing with a distance, with a length, with a perimeter even like the distance around a thing is still one dimension. And so it would be used with just good old units of measure, like centimeters or meters or yards or feet. We're just measuring one dimension. And so that's what we had done. And then we get into something else, which is a completely different thing. This is what students don't understand too well. It's a completely different thing. And that's when we deal with two dimensions. And so when we deal with two dimensions, we dealt with area. Okay, so we had area. That was in two dimensions. And so now we're dealing with a different type of unit, a square unit. Okay, so we dealt with square units, squared centimeters, squared meters, square yards, square feet, and that's where we use that exponent of 2 for our units of measure. That was in two dimensions. So a completely different thing than one dimension. And even more completely different is what we're doing in 3 dimensions. What? Yeah, 3 dimensions. We're dealing with volume. And so we deal with volume, and that's, again, a completely different thing because it's an entirely different dimension. Okay, so we're dealing with volume now, and we have to remember when we're looking at volume in 2D shapes, we have to recall what that looks like. The background is dotted lines, right? So the dotted lines is what denotes, hey, I'm looking at something in 3D. But anyway, volume dealt with, like, space of something, and that's a cubic unit. Okay, so a cubic unit to the 3rd power, so cubic centimeters, cubic meters, cubic yards, cubic feet, that all dealt with volume. So to understand volume, we have to make sure that we understand units of measure, how they're completely different from one dimension to the next. And so there's no use in going into anything else until you understand that. So we're going to get into volume, and we're going to start with 2 basic shapes. The first shape is something called a prism. Now, a prism is a 3-dimensional object that has 2 congruent bases. Okay, in this case, we have a rectangular prism because the base is a rectangle. Okay, we might also have something called a triangular prism where the base would be a triangle, but what makes a prism is that we have 2 congruent bases, and we'll get more into that in a second. And so when we're finding the volume of that 3-dimensional thing with a prism, the formula is quite simple. And the way this is read is that we have the capital B, and that denotes the area of the base. So whatever shape your base is, the capital B means the area of the base. Now sometimes the shape of your base has a base, right? So take, for example, this rectangle. It has a base times a height. Or if we had a triangular prism, the base has a base, right? So we have capital B for the area of the base, and then when we'll get into that, you'll see how lowercase b is the base of the base. But we'll get into that later. So the volume of a prism is the area of the base times the height. Piece of cake. Now, what happens if, remember how a prism is you have 2 congruent bases. What if the base was a circle? So if the base is a circle, we now have a new shape called a cylinder. Okay, so we have a cylinder, and the area of a cylinder is the same way. It's the area of the base, or excuse me, the volume of a cylinder is the same way. The volume of the cylinder is the area of the base times the height. The only problem is the base is a circle. Okay, so in the case of a cylinder, the base is a circle. So remember how you find the area of a circle? Pi r squared. So I wouldn't even use this second formula. The second formula is a bit too much to remember. Just stick with your generals, right? The volume is the area of the base times the height. And so that's our basic formulas. We're going to get into that right about now. So let's look at some examples. We'll see how this plays out. So here we're going to find the volume of a rectangular prism. So how does the volume of a rectangular prism work? Remember, the volume is the area of the base, capital B, times the height. So the only question is, well, what's my base? Okay, so if I'm looking at this shape this way, my base would be the 24 by 20 rectangle. That would be my base. But that's not the only way to look at the shape, right? In the case of looking at it this way, the height would be 10. I might also look at it, hold on to your seatbelts, kids. Yo! I can look at it this way, where now my base is 10 by 20, right? This rectangle, and the height of that box looking this way, 24. Okay, so it doesn't matter which way. As long as I have my base, is the two congruent bases is what makes the prism. So as long as you have your two congruent bases, you have your base, right? So this rectangle is congruent to this rectangle, my height is 10. Or this rectangle is congruent to this rectangle, my height would be 24. All right, so that's how the rectangular prisms work. The rest is simple math, right? So I'm looking at, in this case, the area of the base. And so the area of my base is little base times height, right? So the area of my rectangle, because my base is rectangle, is base times height. So in this case, it would be 24 times 20. And so it's real simple to work with that. So I'm multiplying 24 times 20, 24 times 2 is 48, and so that's going to give me an area of the base of 48. All I need to do now is worry about my height. So in the case of this particular, the way I'm looking at this particular rectangular prism, my height would be 10 centimeters, so there's my height. The math is easy. From here you can use your calculator, or, come on, you don't need a calculator. 10 times 48 is 480, right? So we have our 480. Now, the question goes back to 480 what? Okay, so we got to remember units of measure. We're dealing with volume, and so we're dealing with cubic units. So in the case of what we're looking at, we're dealing with centimeters, so the volume would be cubic centimeters. We have to remember that. Okay, let's take a look at another example. What other types of prisms might there be? Well, we can see here in this next example, we have a different prism. Okay, so this is going to be a triangular prism. But how does that work? So you remember how the prism works. You want to look for your two congruent bases. If you look at this diagram with a rectangular base of 6 by 5, it's going to be confusing because where's the other base that's congruent to that? So in this case, no, we don't want to look at it that way. In this case, we should be able to see that our triangular prism goes in this direction where we have the triangle as a base, because now we can see our two congruent bases, right? So that's our triangular prism. We have our two congruent bases is a triangle. So we got to be careful with how we're looking at this. So in the case of this, volume formula remains the same. The volume is still the area of the base times the height. But in this case, we got to be careful. Our two congruent bases are triangles. Therefore, our height is going to be 5 meters. So we got to be careful with how we're looking at this. Now we just need to remember, how do we find the area of the base? Again, in this case, the base is a triangle, and so it's going to be 1/2 little base times height, right? So you remember the area of a triangle is half base times height. So in this case, our triangle is 10 by 6, right? So we have a 6 meter base and a 10 meter height for the little triangle. So our area of the little triangle base is 1/2 the base times the height, which of course is 1/2 of 6 is 3, 3 times 10 is 30, so the area of our base is 30. So we're looking at the volume of the solid, right? It's the area of the base, which is 30 whatever, times the height, and we already noticed that the height was 5. And so now again, the rest is calculator work, or come on, you can do this. 3 times 5 is 15, right? So 15 with a 0 is 150, but 150 what? So remember, units of measure are very important. And so in this case, it's meters, but it's volume, so it's cubic meters. Piece of cake, right? Right, okay. It does look like a piece of cake, doesn't it? Cake. Okay, so let's do another example. Let's take a look here. Now we have another triangular prism, but this one's a bit more confusing because we want to find our two congruent bases. And our two congruent bases are these triangles. So in this case, we're looking at a triangular prism here, okay? So volume formula remains the same. Volume is still the area of the base times the height. So we know our bases are the triangles. Let's go ahead and knock out the height. The height is going to be our 10 inches. We have nothing to worry about here. The challenge comes with the area of the base. The base, again, is a triangle, so we need 1/2 base times height. Here's the deal, though. Look at this triangle. This triangle is messed up. This is an equilateral triangle because we have 8 inches in this way and then 8 inches around here. So how are we going to find the area of that equilateral triangle? So let's take a look at that triangle. So now what we're going to do is look at that triangle and make what I've called in the past a pop-out triangle. So we know our triangles have dimensions of 8, 8, and 8, or this triangle has, that equilateral triangle has dimensions there. We need to draw our height. How do I find the height of a triangle we don't see? We draw it. Okay, so draw it. Here's our height. So since this is an equilateral triangle, if we're looking for our height there, 8 is our hypotenuse of the right triangle. The other leg is 4. The rest is Pythagorean theorem. And we can do this in a couple ways. We can remember that 4 squared plus h squared would be 8 squared. That's Pythagorean theorem. Or we could use trigonometry. Yes, trig comes back! Because in this right triangle, we should know we have a 60-degree angle. So we have a 30, 60, 90 right triangle. Our hypotenuse is 8. Our short leg is 4. What does that mean about the long leg? Our height is going to be 4 times the square root of 3. All of this just to find the height. Or if we use Pythagorean theorem, we can use our calculator. Remember how that works, this little shortcut. We have 8 squared minus 4 squared equals, and then we take the square root, 6.93. Okay, so in this case, the height would be 6.93. In this case, the height would be 4 times the square root of 3. And so we could use either one. Now watch this. 4 times the square root of 3. 3 square root equals, guess what? 6.93. Oh my God, math is awesome. It works out that way all the time. So anyway, just a funny little thing to see. So all that work just to find the height of the triangle, which is the area of the base. So all this work. So in one way we're using the calculator, we have the area of our base, right? The area of our triangle is 1/2 base times height. So it would be 1/2, the base of the triangle was 8 times the height was at 6.93. So we find the area of that way. The trig way is the same thing. 1/2 the base times the height. In this case, 4 times the square root of 3. So in one case, the volume, or excuse me, the area of the base is all calculator work, right? 8 divided by 2 equals that, and we're going to multiply that times 6.93, and we find that the area of the base is 27.72. So in one case, the area of the base is 27.72. In another case, we can use trigonometry. Half of 8 is 4, and 4 times 4 is 16 square roots of 3. So we can also call this the area of the base 16 times the square root of 3. Either way, as we're finding volume, we're still going to need to multiply the area of the base times the height. So our height is 10 inches. Our height is still 10 inches. All right, so in one way, we're using our calculator, and we have, let's see, 4 times the square root of 3. So we could multiply this out. So we have multiply times 10, and that would be 277.2 whatevers. And this 16 times 10 is 160 times the square root of 3 whatevers. And we have to worry about the whatevers. So in one case, when we're rounding, it's cubic inches with a decimal. In the other case, we're using exact values. It's cubic inches with exact values. So either way, we are using good units of measure, and it turns out to be the same. So watch this. 160 times the square root of 3. Guess what it's going to equal? I guarantee you 277.2. Boop. Oh my goodness. Actually, it's going to be 0.1. See how rounding is a little bit inaccurate. So it still works out well. So check that out. That's a neat little, it's going to be a bit inaccurate. Okay, so enough about prisms. Let's get on to the next half of what we were learning about. And it's actually the same thing as we talked about before, but it's going to be volume of a cylinder. So as we did when we looked at the notes, yeah, you could see a different formula for the volume of a cylinder, but I certainly am not going to teach it that way. Remember how volume works of any type of prism-ish thing. The area of the base times the height. It just so happens that this base is a circle. So we're going to work with circles. And this is where we have to read the directions carefully because we're talking about in terms of pi. That means we're not going to be using the abbreviation for pi, and we're not going to be using the pi button. No, no, no. We're going to leave pi as pi, which is no big deal. Okay. So we got to figure out first the area of the base. Now remember, the base in this case is a circle, and it has a radius of 3. So the area of the base, of course, the area of a circle is pi r squared. The area of the base is going to be pi times 3 squared. But since we're talking about leaving it in terms of pi, we're going to call the area of the base 9 pi. So that's how that works. So just remember, old material with working with circles, and new material. And now we're going to deal with the height. And the height of this particular cylinder, 8 centimeters. So we simply multiply. It's all we have to do. This is crazy easy, right? So 9 pi times 8. 9 times 8, 72. So we're going to end up with 72. Don't forget the pi, right? So 72 pi. 72 pi what? Cubic centimeters. So we have to remember when it comes to volume, we got to use our volume units. All right, so cylinders is the same thing as prisms. Area of the base times the height. Is it, Mr. Katz? Yes, of course it is. So even with something like this, look, we're going to find the volume of this cylinder to get in terms of pi. And you might be thinking, Katz, what's it? It's tilted. No, I can't deal with it. Of course you can deal with it. Chill out. The volume of any prism-type object is the area of the base times the height. This ain't that big of a deal. All we have to do is make sure we see what we're seeing. The area of the base means we're going to be looking at this base. In fact, the area of the base is still pi times the radius squared, right? But check this out. It gets even easier. The whole diameter is 2. That means the radius is 1. So it's pi times 1 squared, also known as 1 pi. But since we're not noobs, we don't call it 1 pi, we just call it pi. Okay, so it's not 1 pi, it's just pi. All we need now is the height of that cylinder. And so we're looking here, oh my god, I can't find a height. I don't know what the height is. Yes, you do. Right there, dude. It's perpendicular. The height is 3 meters. So we're just going to multiply by 3. So 3 times pi. In terms of pi, 3 pi. And now I'm hungry. 3 pi what? 3 pi cubic meters. Okay, cubic meters. So that's how that works. Easy peasy. Okay, I'll save the best for last. Look at this mess. It's mess. I love it. We're going to find the volume of a composite figure. So this deals with like a lunchbox, right? And it looks so confusing. How could we even approach this? But this looks so messed up. How do we even approach this? Well, we got to see what we're seeing. And we can see the top part of the lunchbox. It looks like half a cylinder, doesn't it? Doesn't this look like half a cylinder? If it doesn't, look again. It looks like half a cylinder. So picture the lunchbox. That's the three-dimensional thing. That's half a cylinder. The bottom part of the lunchbox is a box, or rectangular prism. Okay, so just call it a box. I don't feel like writing out rectangular prism. I'm lazy that way. So if we can figure out the volume of half that cylinder, and we can figure out the volume of this rectangular prism, add the two volumes together, we are peachy keen. So I've done this before. We want to make sure we're labeling things correctly. So if we're going to look for half our cylinder, we're going to be able to find the volume of the cylinder. Again, volume is equal to the area of the base times the height, and then we're going to end up cutting it in half. Okay, so we got to be careful. Area of the base times the height. but we're going to cut it in half. So let's deal with that, shall we? Yes. So for the cylinder, we're going to be looking at the area of the base, but the area of the base is a circle, right? The base is a circle, pi r squared. So the area of the base is pi times the radius squared. In this case, if this is 3 inches, there's your radius. Pi times the radius squared, or 9 pi. And now we have the height of the cylinder. So we're going to look for the height of the cylinder. How tall is that cylinder if the circle is the base? How tall is the cylinder? It's 10 inches. 10 inches. Okay, so we're going to have the volume of the entire cylinder. The volume of the entire cylinder is 90 pi, but that's of the entire cylinder. Don't forget the halfies. So we have to cut that in half, and if we take half of 90, we're going to get 45 pi. Okay, 45 pi. And that's just the volume of the cylinder, just the top part. We also need the volume of the rectangular prism. We also need the volume of that box. Okay, so the volume of the box is now, label your work. So the volume of the box now is going to be calculated again, area of the base times the height. So in this case of the box, we have to remember the area of the base is going to happen right there. It's little base times height, so it's 10 times 6, right? So we can see the area of the base is going to be 10 times 6. 10 times 6. So the area of the base, 10 times 6, also known as 60. And we need the height of the box. So the area of our base was here, right? We looked at 10 by 6. That means the height is 6 inches. So our height is 6 inches. So the volume of the rectangular prism is not that tricky, right? 6 times 6 is 36. Throw the 0 down. 360. So if we're finding the composite volume, right, the total volume, we're simply adding these two values together. So the most exact of values, we have to add them together. And the most exact value, the volume, is technically 45 pi plus 360 cubic inches, right? So I get technical on this, right? But we have to read the directions. The directions are reading. You don't need to do that. That's too crazy. Let's just round it to the nearest cubic inch. That means round it to the nearest whole number. So the rest is calculator work, right? Throw it down your thumbs. So if we use our calculator, we're going to look at 45 times pi. Right? So 45 times pi, delicious. And we're going to add 360 plus 360. And so we have our equal sign, and we can see rounded to the nearest cubic inch. Rounded to the nearest cubic inch is going to be 501. And so we have our most exact value, and we have our rounded to the nearest inch value, cubic inch. And so that's how volume works, okay? So check back in later, folks. We're going to keep going through the unit on volume when we're dealing with pyramids and cones and spheres even too. So hopefully you'll learn some stuff. Peace!